if I want to start with that, what, if you guys recall, what was the first way you guys all learned how to graph, no matter what it was?
Y equals x plus a.
Okay, but how did you pick your points? You made what?
Um,
You made a little table, right?
Yeah.
Okay. Well, if I'm going to do it this way, when x is 0, what's y?
0.
Good. Square root of 0 is 0. What's the square root of 1?
1.
What's the next perfect square? 4. Good. What's the square root of 4? 2. So what happens here is that this graph, oops, kind of looks like that. Now, excuse me. If I'm looking at this, what's my domain? That's not what I'm thinking about here. Remember what domain means? Domain is your x values. What are all your possible x values for this? Can it equal 0? Yes. So in this case, x is greater or equal to 0. I cannot have any negative values here because I'm not taking any negative square roots. Also, what's my range? Remember, domain goes with your x values, range goes with your y values. D comes before R, x comes before y. What are all my y values here? Also, y is greater than or equal to 0. Okay. In this section, you're going to start, they're going to bring back domain and range a little bit, which really isn't all that bad. So when we start to talk about working with square root functions, whether or not they have a full shift or an amplitude shift, we always look at basically these 3 points to start with. 0, 0, or excuse me, the x values of 0, 1, and 4. Because all of those guys are perfect squares. What happens now is that you're going to see stuff like the following. Y equals, I'm going to show you what's called an amplitude shift. That value of 3 is an A value. What we're doing is we're graphing a generic function of y equals the square root of x. So again, when I go to start a graph of something like this, I'm not using graph paper. I'm starting out with my xy grid. When x is 0, what's the square root of 0?
0.
What's 3 times 0?
0.
Okay, so it still starts at 0. What's the square root of 1? Bless you.
1.
1. What's 1 times 3?
3.
What's the square root of 4?
2.
What's 2 times 3?
6.
Do you see what we're doing? What's changed here is that I've changed the rate at which this is climbing, if you will. That A value changes the rate at which how fast this curve goes up or goes down. If the A value is positive, it's a first quadrant problem. What if the A value is negative? Can I have a negative A value here?
Yeah.
Yeah. If it was negative, let's say it was y equals the negative square root of 3. At 0, it's still 0. At 1, it becomes negative 3. And at 4, it's negative 6. It's just going the other direction. So that A value is just basically telling you how fast or how it's increasing or is it's decreasing. Okay? What comes into play then is that shift. Would you like me to shift a square root, or do you want me to explain the cube root first? Want to do the cube root? Because the shift is the same thing, either one of them. So let's just look at the cube root then. So, generic idea, when you're dealing with square root, you're looking at 3 points, 0, 1, and 4. Multiply it by whatever your A value is, bada bing, bada boom. When I'm talking about a cube root, can I have a negative cube root? Yes. So when I'm looking at the rough sketch of a graph of that, again, start with 0, because what's the cube root of 0? What's the cube root of 1? What's the cube root of negative 1? Negative 1. What is the next cube root after positive 1? 8. Good. What is the cube root of 8? 2. So for all intents and purposes, do you agree that the graph is going to look like this? Yeah, similar, isn't it? It's scary, right?
Hey.
What's your domain? Is there a restriction on your domain here?
Yeah.
Is there any values that x can't be? No. So if there's no value that x can't be, what would you say your domain is?
Infinity.
No.
X. All real.
Hang on. Yes, sir. Oh, no question. Is there a restriction on your range?
Wait, how do you know if there's a restriction on your domain or range?
When you think about the square root graph, well, we're talking about real number values here. Can I take the square root of a negative?
No.
So I can't graph it, can I?
You can graph it imaginary.
Right, like we are right now?
Yeah.
We're talking about real values here. Okay, we're talking about real values in this stuff. So no, so there's no, so there's restriction. There's going to be restriction on your squared function. No restriction usually on your cube. Okay. And it's very obvious when you start to see this. Okay. So again, if I throw a value of a in here, let's say, for example, I say it's -2. I'll just use this same thing. If I plotted my original values of, I'll just write it on separate. If I say that y is equal to -2 cube root of x, and I wanted to sketch that, again, all I do is start with my xy grid. I know that the cube root of 0 is, so I start with that.
When we graph on the test, are we going to be able to use our calculator?
I don't know. Then we get to this part. What's the cube root of 1?
1.
What's 1 times -2?
2.
What's the cube root of -1?
-1.
What's -1 times -2?
2.
So, it's just going the other direction. Is there a restriction upon your domain and range?
No.
Nope, it's all real for both of them. Okay? Like I have stated in the past, I shouldn't say in the past, but I think I mentioned to you guys on Monday that the graphing portion of this is relatively straightforward. There's not a lot of craziness here. The shift can be. So we just got to be careful with it. So let's talk about the shift.
Like a football game.
Not necessarily.
It's this.
What happens here with your shift? You have your A, H, and K again. Where H and K stand for your horizontal or vertical shift, which means your H moves your values left and right, and your K value moves them up and down. But each and every time you go to graph one of these square root or cube root functions, because that's all we're going to worry about graphing in here, is that you follow the same exact pattern. You always start by labeling what your A, H, and K are. So if I'm looking at the example of y equals the square root of x plus 1 minus 3, notice how this is outside of the radical. What is my A value?
1.
H, -1, and K. So that means I'm going to move all of these points when I plot them left 1 and down 3. How does this look? Your first step is to always graph what's called a parent function. The y equals a root x in this case. For each and every one of these, you're going to graph what y equals a root something. In this case, my a value is 1, so it's a really, really easy graph to sketch. What's the square root of 0?
Yep.
What's 0 times 1?
0.
Minus 2.
So here I'm graphing the parent function of y equals the square root of x, because my a value is 1. What's the square root of 1?
1.
And then I have to use 4. So after I've plotted those 3 points for my parent function, I dot them to connect them. Like that. So the last bit then is the shift. I know that each and every one of those points has to move to the left 1 and then down 3. So I start with the first one. I go left 1, down 3. Left 1, down 3. Left 1, down 3. And there's my new graph. And I make it a solid.
Looks like a little shadow.
Yeah, kind of.
Just being a shadow.
No, leave your dotted, because I'm going to require that you guys keep your dotted and your solid on there.
What if I don't do the dotting?
Then you'll be half right, because it'll say draw the dotted and the solid. So, yes, sir.
So K is you move it left horizontally.
H is horizontal. H horizontal. K vertical. Vertical is up and down. Now, on your shifted graph, what's your domain? X is greater than or equal to -1. What is the smallest possible value of x that we have here?
-1.
-1. What is the range?
Right?
Good. Y is greater than or equal to -3. So your domain and ranges have changed. Because if you think about it, if your domain and range for your original graph started at 0, 0, if it's moving left 1 and down 3, wouldn't your domain and range move left 1 and down 3? Same idea. Okay? So when you graph these, yeah, I'll ask you guys to graph the parent function with the dotted, and then shift it with the solid. No, you don't have to have 2 colors. Not bad.
Not bad.
Let's try one with a cube. Let's try this one. Y equals -2 times the cube root of x minus 1, all plus 2. First thing we're going to look at here are labeling A, H, and K. What's A? -2. H?
1.
K?
2.
So step 1, we're going to plot y equals what? We We start by plotting the -2 cubed root x. Use the 3 points that are easy to work with. I know it's going to be 0, 0, no matter what. Cube root of 1 is 1 times -2. Then it goes the other direction. Connect them via dots. Do I have to worry about domain and range of the cube root function? And now I just have to shift everything. I have to move everything to the right 1 and up 2. And there's my new graph. H is positive. And as we get into more into the second semester stuff with the graphing, H's and K's, it's the same thing each and every time. You plot the parent function with your A, whatever you're doing, and then shift it. Yes, sir?
So would you say that the these two graphs here are parallel?
Parallel deals with lines, but I know what you're getting at, and I would say yes, because I know what you're thinking, but I don't remember what that is called. It's called something.
They just go in
Yeah, they're never going to intersect. You're right. They're mirror images. Yeah, they're.
Parallel images?
I know it's called something. We'll make up a word. It's parallelity.
Yeah, let's
Parallelity. Sure. Yes, I'm making up words. Welcome to my class. All right. Try this one.
Okay.
You know what? Let me put this. I'll put this on with this a cube root at the same time, so you guys can do two of them. Here's a cube root. Wait, I just did that one.
Oh, wait. What are we doing?
No, it's opposite.
No one will allow more.
Do those two for me, please.
Okay, so
This one. All right. So when I go to start it, 0, 0. At 1, it becomes -3.
yep.
At 4, it becomes -6.
All right, I can't go down that far with the other page.
Is that right?
Yeah.
Now when you shift it, you're going to the right 2 and up 1. So if I go right 2 and up 1, right 2, up 1, right 2, up 1. Kind of like that.
Yep.
Now, what's your domain?
X.
Greater than or equal to 2. You always go your domain off of your shifting. Okay. And then your y values are your range. What's the highest peak on the y value here? 1. See how the y value doesn't get any larger than 1?
Okay.
So I'd say y has got to be less than or equal to 1. Does that make sense?
Yes.
Okay. So tonight, yes, sir.
You do your domain and range off of the shift.
Yeah, always off the shift. So what I've got tonight then for you guys is that I've got 2 sheets for you.
Why?
Both of them are mainly review stuff.
It is a good book.
Guys, I don't want to have to explain this 4 times. Please. On this first one that I'm giving you, you will find that there are 6 graphs. So do the 6 graphs first. Then start working on the review stuff. Especially paying attention to working with your exponent rules, simplifying of radicals, and things like that. The other sheet that I have is more of the same style problems. There's no graphing on it. I don't know if I counted right.
So we
There's
do this
no
on.
graphing on it, but it's just review stuff, and it comes with an answer sheet.
Should we do this on the surface sheet bit?
Yeah,
This is on the correct.
yeah.
So these graphs.
So wait, we can't write it.
No, you can write on it. I'm just saying, it'd be easier to do the graph problems on a separate sheet.
Is this just graphing?
And all this graphing is we've done today.
Nothing's changed,
We
honestly.
already.
Okay.
And then you can.